Okay, what's the difference between 4 and 5?
One's left.
The other one you don't reflect.
Oh, this one I'm taking one away. Once I pick my card, I'm not putting it back in. So, how many different ways can two cards be drawn? The first time I pick, I have 52. The second time I pick, I only have 51. Okay, so my total is 2,652. Now I'm not placing that card back into the pile. I'm keeping it. So it lowers down my chances every time. Okay, what's the probability of drawing 2 5s? How many 5s do I have to begin with?
52.
I 5.
Four.
4 5s. I picked a 5. Now how many do I have?
3.
3. Divided by 2,652. Okay, because you're picking the same thing twice, it goes down by 1. Okay, so we should end up with 1 over 221 here. What is the probability to draw 2 cards with number values? How many cards do I have that have number values on them?
36.
2, 36. Okay. 2, 3, 4, 5, 6, 7, 8, 9. That's 8.
Times 4.
I don't like cards.
Not times 12.
8 times 4 would only be 32. They're counting the aces. No, the 10.
It's 2 to
10.
10.
I'm forgetting 10. That's what I'm forgetting. 10. Okay. So there's 9 cards that are numbered and 4 different suits. So that means I have 36 numbered cards. I pick out a number card.
35.
I only have 35 now. Again, divided by the total possible. And this should give us 105 out of 221. Now I want to pull 2 black cards. What do I start with? How many black cards do I start with? 26. When I take one, I now have 25. So this total should be 25 out of 102. The last one. Do not let this one throw you for a loop. What is the probability to draw 2 cards of the same suit? So it doesn't matter what card you pick the first time. How many do you have to pick from? 52. Let's say you've now picked a diamond. How many cards do you have left to pick from if you want it to be the same suit? Or even a spade. Let's say you've pulled a spade. How many spades do you have left now? 12. Remember, you have 13 of each suit. Again, it doesn't matter what you pick from the first time because it's not telling you a specific suit. So you can pick any one of the 52. Once you've picked that specific suit, now you only have 12 left in that suit. Again, out of 2,652, which gives me a 4 out of 17 chance to pick 2 cards that are the same suit. Remember, too, this is theoretical probability. This is not experimental. This is what could happen, not what does. All right. So, multiplication principle for independent events. If I'm pulling E and then F, I can do the first one times the second one. That's kind of what you've already been doing. So, tossing a coin twice. You take your first probability of flipping times your second probability of flipping. Rolling a die consecutive times. Choosing a card consecutive times. We've just got done doing this. So let's practice some more. If my event is dependent, that means a deck of cards is shuffled and 2 cards are dealt. What is the chances that both are aces? Independent versus dependent. What does it mean for something to be independent or dependent? Independent, by itself. Okay, so this is replacement. Okay? Or a roll of a die, because you're not taking away any options. A flip of a coin, you're not taking any options away. If you're taking a card out and replacing it, it's independent. So dependent then would be non-replacement or no replacement. Okay? Because if I'm taking a card out of a deck, that means the second time I don't have all 52 to choose from. It's dependent on what happens beforehand. So, example 1, 7 red marbles, 5 green marbles, and 8 yellow marbles are in a bag. Each time a marble is chosen, it's placed back into the bag for the next draw. Is this independent or dependent? Independent. I'm putting my marble back into the jar. This is independent. So, first thing I would suggest you do is get a grand total of marbles in your bag. If I have 7 red, 5 green, 8 yellow, how many marbles are in my bag? 20.
20.
Okay. Red, then yellow. Probability of red. 7 out of 20. Then yellow. So times probability of a yellow.
8.
8 out of 20. Fantastic. 0.14. All that then means is to multiply the two. Yellow, then red. So yellow first, then red. 8 out of 20. 7 out of 20. Guess what? Same thing. You're just flipping the order.
Magic.
Okay. C. Red and yellow.
8
This was the one where we had to add. Okay, because remember, you can have red then yellow or yellow then red. Okay. Well, let's see. You've done red then yellow. 0.14. You've done yellow then red. Let's add the two. What's my chances then? 0.28. Okay. Remember, this and means you can do red and yellow, which was that, or you can do yellow, then red, which was that. So if I just take the two and add them together, I'm done. Because you've already done the two that need to go together. Okay, probability of red, then red. What's the probability of red? 7 out of 20. What's the probability of red? Fantastic. 0.1225. I am just going to kind of throw the answers out there because I'm more worried about can you pick the fractions that we need to use. Probability of red, then green. Red.
7.20.
Green. 5 out of 20.
5 out of 20.
0.0875. And then finally, green, then yellow.
5 out of 20.
5 out of 20.
Times 8 out of 20.
Times 8 out of 20. 0.1.
That's nice.
Any questions?
No ham. No ham or turkey.
No ham, no turkey?
No ham, no slam, no bang.
No, but
I was about to cut by accident.
I'm glad you didn't. I'm glad you refrained yourself.
Is this
Ooh, the next one, no replacement.
The next one's no replacement.
They do 7 out of 20, then you
Okay.
pick one.
So,
They got 19.
this might be the last one we get to before y'all leave. Oh, no. 12:50. Okay. So, we should be able to finish this and jump into binomial probability before we leave. Okay. So, the only difference here, Bree already said, no replacements. I'm not putting my marbles back in. Once I take it, I keep it. So, red, then yellow. What's the probability of red? 7 out of 20. Now I want a yellow. 8 out of 19.
Oh, I did it right.
My bottom number goes down. Why does my top number not go down?
You got 8 marbles and
I switch colors. It's basically what it boils down to.
There you go.
Okay? So I'm not taking the same color. If I'm taking the same color, then my top and my bottom go down. What about yellow then red? What does that look like? Yellow first. 8 out of 20. And 7 out of 19. Guess what? We still get the same answer.
Wait a minute, why would it
You
be
still
that?
have 8 and 7 in the top and 20 and
It
19
just-
in the bottom.
it goes down.
Wait, why does what have what?
No replacement.
This is no replacement. So once I take a red marble, I don't put the marble back in. So my marbles go down.
Once replacement, it will be to the second, right?
Okay, what?
If there was replacement, it will be like to the second or something, right?
Yeah, technically, well, no, because you've got two different numbers. You can't do 7 to the second when you have 7 yellow and 8, or 7 red and 8 yellow. Okay, so Bree said, oh man, here comes that and again. So I need to add, I need to do red and yellow or yellow and red. Okay, so red then yellow, we got 0.147 plus yellow then red, I got 0.147. So you get 0.295.
And then for me, I'm gonna do 7 over 20, I'm 6 over 19.
Okay. D, I have 7 out of 20. Uh-oh, I'm picking that same color again. So now it's 6 out of 19. That top number also has to drop because I'm picking the same color over again. So 0.111.
All in one.
All them ones.
Oh, them ones. Like in the club.
Yeah, you know that go.
Question. Okay. Rolling a die 4 times. What's the probability of getting exactly 3 ones? How do I write exactly 3 ones? What did I use for exactly something? C. We used C.
Oh, yeah.
Whoa, it's back.
Oh,
So you do 4,
yeah.
4C what?
I thought it was 3 for exactly.
4C3. I'm rolling it 4 times, and I want ones to show up 3 times.
I thought it was 3 for exactly.
Huh?
No, because I'm not asking for an order.
Is it telling me that my 1 has to come first or my 1 has to come third?
Oh.
No, so that's what makes it C. Okay. Now, let's see. I need a 1, a 1, a 1, and anything but. Okay. What's the probability of getting a 1? 1 out of 6. What's the probability of getting a 1? 1 out of 6. How about another one? 1 out of 6. What's the probability of not getting 1? 5 out of 6. Okay, so you would have to multiply that all together. This shows your exact. This shows the probability of each time you want it. And this is the probability that each time that you don't want it to happen. So you want the 1 to happen 3 times. So you take the 1, 6, 3 times. Happen once. So you multiply that once. You get an answer of 0.015432. Okay. I'm going to give you a shortened formula that you see down below this problem. Okay. You're not getting rid of this. This is stuck here. Every time you need an exact, you need to have that. Okay. So this is never going to go away. After that, you're going to have the first set of parentheses. This is the probability it will happen. Okay, I don't know how you need to maneuver it so it all fits in there. Draw your little arrows and write it somewhere. Okay, so inside that first set of parentheses, after C, is the probability that it will happen. This value right here is how many times it needs to happen. In this second set of parentheses, you need the probability that it won't happen. Okay. And then this value up here is how many times you don't want it to happen. What does what? It says times it needs to happen. So if I want exactly 3 ones, I would raise it to the third because I want the ones to happen 3 times. Okay. Once we do a couple examples, this will all start to fall into place. I think my wording is a little bit better than you sitting here going, wait, N is this, K is this, P is that, what, huh? No. Okay. We got 10 minutes. We got time to probably do 2 or 3 examples before we walk out of here. I promise we do. Okay.
Exactly.
Waiting for everybody to get these words down so they have them. Hold on a second.
Oh, wait.
You got all this down?
Yep.
Okay. Anybody need me to reread anything that I wrote? So you understand it?
we don't.
Nope.
Yeah? No? No, yeah, no, yeah, no. Good news. Fantastic. All right. We're rolling a die 6 times. What's the probability of getting exactly 3 ones to show up? Okay. So how do I write exactly 3 ones out of 6 times?
63.
6C3. Okay. I want a 1. What is the probability of getting a 1? Prob of a 1. You said it's 1 out of 6. Okay? So that's what goes into your first set of parentheses. What you want to happen. I want the probability of a 1. How many times do I want that 1? 3. Okay? In the second set of parentheses, we want the probability of not a 1. What's the probability that I'm not going to get a 1? 5 out of 6. If I want 3 ones to show up out of 6, how many times do I want a 1 to not show up? 3. That's it. Okay, another way to look at this. This number that goes here goes here. If you subtract these two, 6 minus 3, this number goes here. That will happen every time. When you plug this in, this becomes 0.0536. Okay, let's try another one. I'm tossing a coin 4 times. What's the probability of getting exactly 3 H's to show up?
4C3.
4C3. I'm flipping it 4 times. I want 3 exactly. Okay. Probability of getting an H. 1 out of 2. How many times do I want that to happen? Well, I want it to happen 3 times, so that number goes there. If it's not a heads, it's got to be tails. What's the probability of getting a tails? 1 out of 2. I wanted 3 of my 4 tosses to be heads, so how many needs to be tails then? 1. Again, if you take 4 minus 3, you get 1, and that answer becomes that exponent. Okay, does that make sense?
Yeah.
The first one's confusing because it's the same number over again. You would plug this into your calculator. Okay, which one of those is right? He has 0.375, and I made a note that it's 0.25. Somebody plug that in. You got 0.25. Okay. Let's try one more before lunch. 4 red marbles, 8 green marbles, 6 yellow marbles are in a bag, and each time a marble is chosen, it's placed back into the bag for the next draw. What is the probability of exactly 4 reds out of 5 draws? So it's 5C4. I'm drawing 5 times, and I want 4 of them to be red. What's the probability of red? 4 out of 18. How many times do I want it to be read? 4 times. What's the probability of it not being read? Okay, take a look at this. If this is 4 out of 18, what do I need to add to 14 or to 4 to get 18? I can add 14 to get 18. Or you can add up your 8 green and your 6 yellow, and that gives you your top. Okay? If I want 4 of my 5 draws to be read, how many need to not be read? 1. Fantastic. So this is 0.00948. Probability of exactly 3 greens out of 10 draws. 10C3. Probability of a green. 8 out of 18. And I want that to happen 3 times. Probability of it not being green. 10 out of 18. And I want that to happen 7 times. You guys are golden.
For real, golden. Oh.
Probability of exactly 8 yellows out of 12 draws. 12C8. Probability of yellow. 6 out of 18. How many times do I want that to happen? 8. Probability of not yellow. 12 out of 18. And how many times do I want that to happen? 4. And you get 0.149. Fantastical. Shake it off, and we will start back up after lunch.